Cool, we're live, no? How do I show myself here? There I am. All right. Trying some new stuff with OBS here. So let me know if anything sounds, looks, or feels funny. Hey, Jose. Alright, this is leftover C stuff. Looks good to you? Awesome. Thank you. This is a lovely stream. No, so we're going to be in here. We don't need this silly book. And we can make that nice and big. Cool. All right, we'll wait a few minutes here, maybe 2 minutes for people to get on, trickle in here, and then we'll get started. So I'll let, in the meantime, you all admire this lovely syntax. Was I able to get the treesitter working? No. I mean, the parser's working. In NeoVim, no. I don't, yeah, I literally, for both Humble and Lovely, I haven't done a single piece of work off stream or off video. And so everything, like where I end in the last stream is where I start the next stream always. So you can always kind of count on that. So yeah, we probably going to try to figure that out today. Hello. Let me start casting. Why is that not showing up anywhere? I'm not seeing keystrokes. What is this? Quit that, try it again. Keycaster. There we go. Oh dear. Okay. There we go, and there we go. Even though I'm at the beginning, because of you guys, I have fell in love with coding and cybersecurity in general. Thank you. That's super awesome, man. Makes me happy. All right, well, we'll get started here and, you know, let people join as they join. Hey, you know, it was cool that happened today and yesterday. I hit the threshold for monetizing on YouTube. So now, in theory, YouTube should start paying me, which is pretty fun. Probably not very much, but it's better than nothing. I think you can do, yeah, pay the man. Jose's got it. Cool. So, all right, this is maybe not going to be fun initially because it's kind of like digging around in documentation. Hello, Arik Fajar. All right, how can we get this to work? So where did we leave this? Let's jump over to dot files because I think we had a test file over here. Yes, okay. And okay, we have it registering as lovely file type, right? But you know, I don't actually need this. Hello, Beef Viper. But if I go like inspect tree, I get this big ugly error, which isn't the coolest thing ever. All right, so let's pull. Oh dear, that's really big. That's better. NeoVim treesitter, right? This guy. That's really slow. Why is this being so slow? Is everything this slow? No. No. Okay, well, adding parsers. Right, so we kind of went through all these steps, but now we're getting that error. But it did install, right? Like if I ts install lovely, so it's already installed, but if I reinstall it, ooh, it says the ABI version mismatch. Okay, so that's interesting. How do I get those messages to come back? Wait, this says it has been installed. This is going to be sick. I hope it is. All right, let's try that again. ts install. So I don't know how to get those messages, so I'm just going to take a really fast screenshot like our ancestors did. Lovely. I'm going to hit yes. Ready? Boom. I got it. I think I got it. Wait, so where'd that go? That'd be this thing. No? Check it out. Could not load parser for lovely. Lovely. ABI version mismatch for, and then it cuts off. That's a shame. But maybe if I shrunk my font size down, I could see more of it. What original language are you currently using to make it? You mean like what language am I writing lovely in? I'm using Rust to write lovely. What treesitter are you using? The same version as the one expected by NeoVim? Yeah, Jose, not Josue. I have a friend Josue too. Jose. Good point, right? Because that's probably the issue. But let's just double check what this error is saying. ts install lovely. Ready? Boom. Okay. Okay, so it's just a file path. So let me make this big again. Oops. So we should check that, no? My treesitter version is 0.253. So 0.25. And what one does NeoVim use? How do we find that out? version of treesitter does NeoVim use? No, it probably isn't. Version. To make sure a parser is at the latest compatible version, specified in NeoVim treesitter's lockfile.json. Where is this lockfile.json? Okay, that could be good. Check health NeoVim treesitter. TS update, lovely. Yeah, I think that would just, oops. Yeah, parser's up to date. I think that would just update, like it would download a new version or something from GitHub, but. That's pretty cool, Beef Viper. Sounds like a fun project. Let me move myself down here so I'm not hiding behind chat. Okay, and then what was it? Check health NeoVim treesitter. Aldrich. What knowledge is a must for us to build a programming language? Familiarity with whatever language you're going to be building it in, for sure. And then maybe just like general knowledge about programming and languages in general. I don't feel like there's like a huge upfront amount of stuff to know. I mean, to make like a simple language, maybe to make like the next Rust or something, but hey, I'm really interested in low-level programming, like kernels and drivers. Where should I start? I'm not the right person to ask, but where I started was this great book called Low-Level Programming by Igor Zhirkov. I'm still going through it. It's been really great. Oh, check this out. NeoVim was compiled with treesitter runtime ABI version 14. Requires greater than or equal to 13. Parsers must be compatible with runtime ABI. Check this out. Lovely doesn't check any of the boxes. I think H is highlighting, right? H is the one you want. Oh yeah, look, highlights, locals, folds, indents, injections. So NeoVim was compiled with treesitter runtime ABI version 14. Parser must be compatible with runtime ABI. So how do I know what ABI version? Let's go to treesitter. What ABI? Is there any sort of like change log on here? Indeed, I believe NeoVim ships with treesitter now. Yeah. But what version is the question? Treesitter ABI version. mismatch. This is in 2021. Please use an old version of treesitter. There's currently no possibility to generate parsers for ABI 13. That's not a page. Wait, NeoVim was compiled with treesitter running ABI version 14. Required is greater than or equal to 13. Teej. TS uninstall all and then TS install all. That's probably not going to work. We can try it. That definitely didn't work. It's installing all the parsers. That's a lot of parsers. Let's just kind of change some colors. Wait for it, wait for it. It froze. NeoVim froze, there we go. Excuse me, what happened to Lovely? ABI version mismatch. Probably need to upgrade your NeoVim. See, I could upgrade NeoVim, but may also need this. Try doing TS install from grammar. Lovely, like this. Yep, ABI version mismatch. I've never tried creating an imperative language, but you are right now. But I'd always be worried. I end up creating C. Haha. You mean as opposed to like a functional language? Yeah. How can I figure out? Oops. Maybe it's just that I haven't. Like, I haven't made the highlights yet. Maybe it would just start working if I did the highlights. I'm just sort of doubtful that it would. Just seems like C is so well designed, it'd be hard not to keep stealing from it. C definitely has its rough edges. That would be dumb UX, but yeah. Maybe install from the TS install from grammar. I tried that, it didn't really work. Let's try just making like one quick test highlight. Didn't it say something in the documentation like over here? Adding parsers, and then you add queries, right? Note that neither TS install nor TS install from grammar copy query files from the grammar repository. If you want your installed grammar to be useful, you must manually add query files to your local NeoVim treesitter installation. Note also that module functionality is only triggered if your language's file type is correctly identified. Yeah, NeoVim does not take your language's file type by default. You can use NeoVim, so I did that. Okay, we're gonna try this. Add some queries. Okay, wait, a few things. It has rough edges, but it's funny when people complain about semicolons and curly braces, but if you remove those, you end up with something like Python, which cares about white space. Yes, or there's other languages like OCaml, which doesn't care about white space and also doesn't use semicolons and curly braces, at least not for the same thing that like C uses them for. Jose, I found treesitter on your machine. It found treesitter on your machine, and it's using that. Check if it's the same version your version of NeoVim ships with. Just a thought. How do I find what version of treesitter my NeoVim ships with is my question. I'm going to try this query thing. So this is also in the syntax highlighting, right? You go to queries. You put them in queries language /*. Let me just double check because I did this once for then maybe in here I queries. Oh, I just had them right in here. I also did them in here once. So let's try that with comments, right? Let's go to treesitter lovely. Queries lovely highlights .scm. Is that right? We're just gonna have this because we do have a comment thing, right? Yeah, okay, we do have comments. So we've got that. Release notes or something. Yeah, good thought. I'll try that in a second. Let me try this first. So then if I go over here, let me just do this. Shoink. Alright, that should be good. Now I'm gonna open this up. I'm gonna go to I'm gonna go to my .files. Alright, I'm going to go to TS update lovely. It is not up to date. TS uninstall lovely. Now TS install lovely. Now it's installed. Hello, Tez. Lovely still doesn't have highlights. Queries language highlights.scm. Looks like OCaml uses double semicolons. Interesting choice, haha. And it has begin and end statements for code blocks. I think I remember doing that in Pascal. Well, this you don't actually really ever need this double semicolons, hardly ever. It doesn't just use double semicolons where you'd use normal semicolons. Tez asks, what inspired me to start coding? I found a course on Khan Academy when I was a kid, and I just thought it was really cool. Just like, I was able to, it was really basic like JavaScript stuff using like processing JS, so it's like drawing shapes and making like games and visualizations and simulations. I just thought that was fun. And then, yeah. Okay, so one last thing here. Treesitter. If I go to here, it should be. Treesitter lovely does have this. Okay, and then I'm going to open it here. Queries. I'm going to change this to that. Last try. Oops. There we go. Okay. What am I trying to do here? Okay, now if I jump over to my .files, for example, Open this back up again. ITS uninstall. Lovely. And then TS install. Lovely. There's an ABI mismatch. Yeah, that's not working. What if there's a programming language that after finished coding collapses the code to a minimum ones and zeros form, reducing power usage? I don't know anything about programming. I'm not sure that the question really makes a ton of sense. Could you maybe explain it a little bit? Not this one, is this one? Wait, queries are what Gem treesitter uses to extract information from the syntax tree. They're located in the queries/language/star runtime directories. C help RTP. Runtime path. It's this thing. What's this? Oh, so it's just that. Check health vim dot treesitter. Oh, this is different. Min 13, max 14. Oh, check this out. This is amazing. Oh my word. Where'd you find this, Jose? This is like exactly what I wanted. This is why Fen wasn't working before. And then I'm sure we'll see the same thing for Lovely. Sure enough, Lovely ABI version mismatch. Supported expected between 13 and 14. We found 15. So how do we get back down to 13 or 14? We probably need an older version of treesitter, no? But I feel like if I install from grammar, it would maybe be fine. Right. That's the health check of Vim treesitter itself and not the NVim treesitter plugin. Gotcha. We are all learning. Are you using LLVM as your backend or generating assembly using your own backend like GCC? I am going to generate my own assembly. Yep. Okay, so Jose at least just clarified. I don't know if we know exactly what the solution would be yet, but at least we know. So check health vim.treesitter. Down here is our problem, right? Supported between 13 and 14, but we have 15. What version of treesitter do I need to download to, or what version of NeoVim do I need to download? What is my NeoVim version? I'm on some like nightly build. 0.11.0. What's the current version of NeoVim? Yeah, this is pretty recent. Can't I see like releases here? 0.11.1. So the problem is that my NeoVim version is too... Oh, yeah. Okay, it's that my treesitter version is too new. They ship with outdated ABIs. Known problem, apparently. Unless they fixed it here. Do any of these talk about ABI? Tree sitter stuff. Okay, there's a 0.12 night like pre-release build now. Oh, wait, 0.11 is stable? Wait, I'm really confused now. Who knew? Maybe I should get on that. This looks good. Or I could get on this. But then all my plugins are probably going to break. So I'm going to do this one. Mac OS. Download NVim Mac OS ARM64.tar. Okay. ARM64.tar. This guy. Shink. Okay, and then I should have gone to my desktop. And if I xatter -c, that guy, and then tar x, wait, zff, that did something. Okay, so where is my NeoVim? Okay, so I'm gonna okay, so move this guy. I'll just get rid of that guy. Well, yeah. This is 0.1 now, right? So now we have all that. So I should be able to go like NeoVim, then NeoVim. And it's NeoVim. Okay. Cool. And then Jose's saying downgrade treesitter, but Connor's saying mine is working NeoVim 0.11.1, treesitter 0.25.3. That's the version I'll have now. I just gotta, because NeoVim's not my path now, so I gotta fix that. Oops. Oh shucks, I can't even edit this because I'm not even in my path. Do this like our ancestors did it. Oh wait, this isn't even the right place. There you go, this is the old Vim. Where's my path? Path. Here we go. Change this to that. Oh. as a leading dot. There we go. Now we have NeoVim. You guys know about cowpath? This is the greatest of all bash utilities. Okay, so now if I go to, well, yeah, dot files, right? And then do that, and then open this, and then it's working. Okay. That's so great. That's so great. That's so great. I couldn't be happier. Oh my goodness, look at this. It like shows me like in the tree where I am. This is fantastic. Okay, so it should be all downhill from here. I'm hoping. Fingers crossed. Okay, that's like the best feeling in the world. So close that. What is this? Okay. So okay. So this is totally working. If I inspect, tree, there's chat right there. If I go right here, if I inspect tree, it's working very nicely. Okay, so now I need to figure out how to actually do this highlighting stuff. So we'll go over back to our treesitter. Lovely. We have this like this. I'm not sure if this is what you actually do with it. Something was suggesting doing this, and then putting this in here. I don't know. We'll try that. Git save. We'll rebase all this later, and then jump back over to dot files. These guys. All right, and then we'll get rid of that, and then we'll go here, and then we'll jump over to test.lovely, and then we'll actually need to update this. So ts update lovely. Shrink. That's already updated. That can't be right. ts uninstall lovely. ts install lovely. Now it's installed. Maybe if I like quit NeoVim and try again. All right, how do we get these highlights to work? So that should be over here somewhere. Shoink. Adding queries. Queries are what NeoVim treesitter uses to extract information from the syntax tree. They are located in the queries, but where does the queries go? Query / language / start runtime directories. See help RTP. Like the queries folder of this plugin, e.g. queries, language, local. Okay. Other modules may require additional queries such as folding. Find a list of all supported capture names there. Okay. The first query file on runtime path will be used. Oh, help treesitter query. That's what I'm talking about. Help treesitter query. Ta-da! Treesitter queries are a way to extract information for the purpose of highlighting. Briefly, a query consists of one or more patterns. A pattern is defined over node types in the syntax tree. Hold on. The pattern may optionally define captures and predicates. Okay. Queries are written in a Lisp-like. Yep, I've done this. Okay. NeoVim looks for queries as a star.sem files in a queries directory under runtime path. What is runtime path? What is runtime path? Is that some command? Runtime path? No. What is runtime path? NeoVim runtime path. Get your current runtime path via NeoVim API, NeoVim last runtime path function. Let's try this. Whoa. That was promising. Wait, that's just my config, my NeoVim config. Tell me how to just like stick it in here. Config NeoVim. In here? That seems odd. Queries. Lovely. Highlights. Do you guys see this? This is amazing. Okay, so comments actually look like comments now. Isn't that lovely? Wow, this is so fantastic. All right, so we just got to fill out the rest of those, and then this will start looking like nice. Okay, I remember somewhere I found like a giant list of all the different possible things. Actually, I think it was in the Z documentation. Docs. Using Z, configuration, extension, installing extension, language extensions. These things, here we go. This is a comprehensive list of captures supported by themes. Cool. So we just need to, you know, see which of our tokens fits with which of these things. We can close that out, keep this open on the side, and then start filling this out. Okay, this is really fun. So let's start with some basic things here. So, or maybe, yeah, we don't really have booleans yet, do we? It seems like a slight problem. All right, comment. We already did comments. Ooh, there's dot comments too. See, we should probably do dot comments at some point. This would be a dot comment, I think, if it has a double octathort, or maybe triple, probably double. I don't know. We don't have to worry about that yet. I don't know. How do we even start? We'll start with some like basic stuff like int literals or numbers or something. Where is that? Or we could do keywords. We don't have much in the way of keywords though. Really just fun is the only keyword, isn't it? Is fun our only keyword? Oh, here we go, number. Check it out. All right, so what is our, what does our, we'll have like a literals. Well, I don't actually know what comments look like in here. Maybe they're this. Maybe they're this. Maybe they're this. Seeing as it's highlighting correctly, if I do it like this, we'll do that. Okay. Literals are, if I have, what do I even call them? I'm going to open up a new window. Put it like, I don't know, somewhere else. Right here. If I go to treesitter lovely. So you don't actually need that, which is interesting. If I go over here, what's going on here? Hello? Okay. Int literal maybe is something. Okay, this thing. Int literal is what we have. Okay, so I'm gonna make a int literal should be styled as a number. Do you have to like quit? Check it out. They just turned purple. Alright. This is very nice. So then what else might we have? Alright, we also have operators, right? Operator. So we'll do operators. What are our operators called? I feel like there used to be a way to I forget. Oh wait, control. Shucks, I forget how it's done. What's this? Operators, because we have, oops. Oh, we don't have, operator isn't actually like a thing. Maybe we should make it a thing. Yeah, because we're just kind of doing this. Well, can you just match on, oops. Could I match on, like, what was that fan? This thing. Oh yeah, you can just do this. Check it out. You can match like on a raw string. Showing, so I'll do not that, but operator, and I'll do that for, you know, that. Got a bunch of these. Plus, minus, times, divided by, exponent, and then we have like greater than, less than, equal to, not equal to, greater than or equal to, and less than or equal to. I think that should be all of them. Yeah, cool, they turned orange. We don't have modulo yet, but one day we will, don't worry. Cool, type, is there like a type thing? Type, captures type, sure enough. So we'll do type, I think we have a type. Type. Check it out, we got types, okay. So we'll do, I don't know, maybe this falls under miscellaneous. I don't know. Type becomes a type. Oh yeah, they turned yellow. What about like what's a semicolon, or like these colons? They're just like weird syntactic things. Punctuation maybe? It's probably punctuation. Oh, there's also punctuation brackets. Oh, punctuation delimiters. List marker. What's the difference between a list marker and a delimiter? Okay, so we can do some of that. So like punctuation. If I have a semicolon, that's just like a punctuation. Punctuation just punctuation, I guess. If we have this or this, That's punctuation dot bracket, I guess. Same with this and this. Invalid node type. Wait, we actually don't have this, but there's no way it would know that. Wait, what? How does it know this? Escape it? Doesn't do anything. Somehow this thing is aware of our syntax. Do you see this? If I do a double equal, it's fine. If I do a triple equal, it's not fine, because it knows this isn't one of our node types. What language server is running? Is this like built into NeoVim? Because if so, this is like the coolest thing ever. Do you guys see this? It's aware of our syntax. I'm getting errors when I use syntax that doesn't exist yet. Like, it knows that double equals, and it knows that bang equals exists, but it knows that bang bang isn't actually a thing, or bang space, or bang bang, or bang bang equals, or bang equals equals isn't a thing. Yeah, this is total wizardry. Who did this? And this is amazing. That is nuts. So we're gonna call this that. We have commas. This would be a punctuation. I would call this a delimiter, but maybe it's a list marker. What do you guys think? Like, what's the difference between a delimiter and a list marker? Aren't those like the same thing? I don't know. Like, it knows that we don't have comma comma. That's so strange. That's like the strangest thing to me, but it's actually really cool. So if I open up this guy now, nothing really changed. Maybe because it keeps that stuff white. Okay, so we'll make it keywords now. Highlights. Do we have a fun keyword? Like, where is fun? Oh yeah, fun is just a thing there. Okay, so we can just check the string. Fun. Well, you are matching the parser with the highlights. Yeah, I know. It knows how to do it, but it is pretty crazy that they actually built it in. So keywords. For now, it's just fun. Is that what it's called? Keyword. Was that a right thing? Key F. Where's the alphabet? Keyword. Oh yeah, right there. Okay. Check it out. Fun turned red. All right, these guys. Oh, I forgot about the tilde. All right, all other idents, I guess. Oops. What are they called? Ident. Oh, we're gonna call unit a keyword, right? and we're gonna call idents. What are those called? Where's I? L, H. There's no I. Variable probably. Call that a variable. So it didn't actually change anything. This is still looking a little bit drab. Alright, there's got to be a lot more of these things we could use here. Like, why isn't this parsed as a type? Oh, because now it's being overridden and it's being parsed as a variable. That's bad. Alright, so I need to update this guy. Right, because what is a type? A type just contains an ident, which is not very good. So I'm going to rename this ident to variable ident. And this should be a type ident, which doesn't exist yet. So we'll make that. Type ident, it'll literally just be kind of the same thing as an ident though. It'll look a lot like this. Except for it has to start with a capital letter. It can't start with an underscore. Well, maybe it can start with underscore. Cool. So there's that. And so then I'm going to just real quick git save and git push origin master. Oops. And then jump back over here. And then over in highlights, I'm going to switch this to type should be, well, that should still work actually now. All right, and then I'm going to ts uninstall lovely, and then ts install lovely. All right, and then if I open up what is happening? If I inspect tree, this is a type. Well, it still has an ident in it. Why are we not having the correct? Type with an ident. That's not right. I wanted it to be excuse me. Oh, because I have a certain revision set. That's probably why. If I undo that revision, will it give me the most recent one, probably? Probably. So now if I ts update, lovely. Maybe I have to quit this and open it again. If I ts update, lovely. It actually updated it, okay. And that's not encouraging. Type with ident. This is not what I wanted. Why is it doing that? Should be a type with a type ident. Maybe because the tests aren't passing, but I doubt it. Oh, I didn't treesitter generate. But while I do that, I might as well test, and it'll show me that it's failing. As expected. Alright. This becomes a type ident. This becomes a Alright, now if I do this again, come again? Okay, there we go. Now, if I ts update here, what is this? Invalid node type ident. Haha. That's good. Because we renamed this thing. Look. It's even giving me an error here. This is now a variable ident. Alright. There we go. Now those things are yellow. Awesome. What else can we do? Like if I open up a Rust file, what other colors are there? You know what I'm saying? Yeah, Jose, there it is. Great user experience. What? All right, let me like copy this and then go over to some Rust project like Lovely. So if I were here and I quit out of this and open it again, oh dear. Now I open this, it looks like that. So during the morning you create an OS and then in the afternoon you create a new language. That's what I've been doing, yep. Function declaration syntax looks closer to Odin. Yep, very much inspired by Odin and Jai. Now if I open up a Rust file, you know, it's got a lot more color going on. Look at all this. Like functions are that color, but I don't really have a way to tell in my grammar whether something is a function or not. Like functions are just values, you know what I'm saying? But I could tell it in a function call. Wait, and look. This type of syntax it's actually a gray, it's not white. Colons and arrows and semicolons. I wonder if there's a way for me to tell. For one, there's an error. It's a little bit disconcerting. Mine, of the ones I know, I'd say Rust or OCaml. Favorite programming language, yeah. And then it's using this blue color for like variants, it seems like, of enums. Is that even one of the things? Variant, maybe? Variant, right there. Alright, well, we'll add stuff in later. I don't need this to be super good right now, but I think this is a good start. So we sort of have some pretty bad syntax highlighting. That's all I really wanted for now. So now, at this point, because like what would make it cool is if all functions were like one color. Sorry, I keep thinking about this. But how can I tell whether or not this is a function, right? Like if I just reference this function right here, how does the treesitter parser know this is a function? Well, how does it know it over here? Let's go to that Rust file again. Does it know that? If I were to just reference some function like self new. How does it know this is a function? It's a scoped identifier. It's almost like the language server is speaking with the treesitter parser. Does that sound right? SP. If I oh, you see that? This turned white. When I restart the language server, it turns white. Oops. And then it turns back green. So somehow, oh yeah, same with all of these. The colors change, and then they turn back when the language server kicks in. How? All right, so that'll be something to look into later on. This will be good enough DX for now. All right, we don't need to be too fancy yet. Lovely's gonna be very fancy though. Okay. Cool, so I'll commit, I guess. I don't know. Well, I didn't really do anything in here. What's going on? I did that, I guess. That's not really good. Yeah, so I didn't do anything in here. So I guess I'll just commit my dot files now. I probably don't want this test lovely file in there. Okay. Updated NeoVim and added support for .lv files. Git push origin master. Uh-oh. When it takes a long time like this, I'm always concerned that I committed my node modules. Eight megabytes? What? Hold on. Do I have my dot files on here? Yeah, check it out. Commits. This one. No. Oh, it's this thing, swiftly.package. Not sure what that is. Oh, it's Swiftly. I don't know why it's there though. Probably won't hurt anybody. Okay. Okay, cool. And then I'll go over to treesitter, lovely, and what's this my focus thing? Focused user? What? There we go. So let's, if I get, right now I got a bunch of save points, right? All right, so I'm going to get rebase -I, take one of these, shoink, and squash, 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 and then rename it all to basic sick highlighting. Now I just have that one command. Okay. Oops. Git push origin master. I'll have to force this one. Cool, so now that's all up there on GitHub too, in case anybody's interested. Now we'll jump back to Lovely. All right, so I'm really glad we sort of got this, you know, partially out of the way. It doesn't look great, but it'll look better later on. What do you guys think we should do next? Where's our readme? This is where we usually go, right? So we kind of did this. Semantic analysis, says ICXD. I didn't even know you were here, man. Nice to see you. Yeah, type checking. But it's also like checking to see if variables are used before they're defined and stuff like that, right? So we also already did that. So, okay. Hello, Thibault M. Okay, should we try that? That sounds kind of tricky. You just arrived, okay. I don't know if you saw, we sort of got treesitter, you know, sort of a little bit working. It's not the prettiest highlighting you've ever seen, but it's, you can tell it's kind of working. We have two keywords, unit and fun, and then numbers and types are different colors. And so are operators. Yep, it looks lovely. Not too lovely yet. I mean, when you look at this and then you look at Rust, it looks like a rainbow, see? So I'm not sure what we're missing really, but we'll figure it out. So you're saying we should go to this step. Well, let me just try some tools. Wait, so this is language, and then tools. Tools we'll want down the road will be like, well, yeah, treesitter, parser, a language server, we're gonna want a formatter, we're gonna want a package manager, stuff like this, right? So just so we know kind of what we need to make. You know, Odin makes functions blue. Yeah, but I was looking at Rust, and it seems like the language server somehow speaks with the treesitter parser somehow to get that, because there's literally no way, if I write here, say like reference calc, which is a function, there's no way for the treesitter grammar to know that this is a function, right? That doesn't come until the semantic analysis step. So, like if you look in Rust, this will start out white and then it'll turn green in my language. Sorry, in my highlighting. In Rust. You're right, but there's a trick you can do. What's the trick? Tell me your trick. So these are things yet to be built right here. Look for an ident followed by a parent. Well, yeah, that works for. Yeah. So that works for like a function call, but it wouldn't work. It wouldn't work here. This is a function. It wouldn't work here. This is a function, right? It would just work here, which makes it look better. But how do you go from not knowing NeoVim to your current config? It looks sick right now. Thank you. I don't really know what I did. I was in VS Code using Vim key bindings, and then I just decided, I'm going to use NeoVim. And then it took a lot of digging around. I spent like probably half of a week initially just like configuring it and trying to, figure out Lua and all that kind of stuff. And then since then I've been like always changing things. That's kind of my philosophy. I know people who like touch their config like once every 6 months or something. I'm always tweaking mine. So that's probably not very good because I probably wasted a lot of time, but it keeps me like always, up to date and learning new stuff. So for functions, you can look for an ident followed by : : but that's not how the language works. This is just like any other variable declaration. Like this is a ident followed by : and it's not a function. This is just a function expression that is being assigned to this. This is like just look more ahead for fun, too. Yeah, could do that, but it still doesn't solve this problem. And I'm also not sure how you do this with treesitter, because you can't really, there's no concept of like looking ahead with treesitter. But anyway, that's not our, like I said, it's a hack, yeah. It's a good idea. So let's we got to work on one of these things because these are the biggies. Probably don't want to, we kind of got this, you know, sort of halfway there. I'm going to make new icons. Let's make some icons. What's a good emoji for like kind of halfway done? Half? That's not bad. I don't know. Let's do something a little more fun. What's an emoji for something that's halfway done? This guy? Minus. Minus. Can you put a minus in here? All right, let's turn all of these into this is partly done, this is not done, this is not done. And this is partly done. A slash. Sorry, language server is not at all done. It actually works with Markdown. That'd be cool. All right, so we'll have this, because if I finish something, I'll do that. So you're saying we move on to this. You think. You're not sure. That's all right. Shouldn't hurt anything. Do type checking. All right, this is where it gets a little bit tricky. Well, the only problem is we only really have two types right now. We have unit and we have int. It's probably the hardest thing to get 100% correct. All right, well, we'll give it a shot. We want, should we make some more types? Maybe like just make a Boolean type real quick so that we can actually do it. Because right now we only have ints and unit. But let's just make a Boolean. I'm just gonna make a Boolean real quick. So we have two types are enough, I know, but like void is kind of a weird type. So I'd rather do it with like two normal types, like int and bool. Yeah, that's something to check against. Let's go, and it'll just take a second. So let's go to our Alexa. We're just gonna make two new keywords. Tokens, keywords. Okay, we're gonna have a true, and that looks like true. We're gonna have a false, which looks like false. All right, and then down here we're gonna have right here. We're gonna have true and false. When we convert these to strings, it looks like true and false. Awesome. Okay, and then we have this. We jump over to here and we just add some new keywords, right? Like where's right here? Here we go. True has 4. False has 5. There we go. Let's add a test. True, false. Sure enough, the tests are failing. Z. Okay, it's right here. True, semicolon, and then false. That should be parsing. Sure enough, it's parsing. Oh, sorry, lexing. And then we'll go over to our AST, and we need a new expression. So we have int literal. We'll probably want like a, you know, like a bool literal, which is just holds a bool. And then, you know, over in the, let's make a test real quick over in here, like up here. We'll do like true, semicolon, false. This should be true. It is discarded. And then we have another one. That is not discarded. That failed. No prefix parse function for true. All right, so if we have true or false, we will go self parse bool literal, which is going to look a lot like this. Parse bool literal. Right now it should be broken. Yeah, unexpected token true. Okay. Match self.cur token. If it's true, we'll do one thing. If it's false, we'll do the other. If it's anything else, then we're gonna have an error, right? Like a expected true or false. All right, if it's true, then we're going to self.expect token true. Return, or just have that kind of thing going on, and then this will be basically the same thing. But false. And there we have it. It works. Okay. So now we have booleans. So now we'll go down here. We'll say get. I'll just commit that. Get. All right. Cool. All right. So now we have to do semantic analysis, which basically is like another pass, no? So we did one pass, lexing, we did another pass, parsing. Now we're going to do another pass, which checks to make sure everything's fine. What is the output of this third pass going to look like is my question. So I'm guessing we're going to want some sort of like another package here. Maybe like what do we call it? Semantic analyzer? Or just the analyzer? or a checker. So we call it a checker. What's a good name? Analyzer, checker, semantic analyzer, type checker, checker. All right, we're gonna call it checker. Now we've got our own little checker. Let's go check out ICs. What's your repo again? This guy, right? Amulet. Wow, you've got your own little README and everything. Okay, source. Checker. We have the scope. Which might have a namespace name. Then you got all the things that are defined in it. Okay. Oh, and I can have children scopes or and a parent scope. Might have a parent scope. If it doesn't, it's the global scope, right? But it definitely has, or it definitely has a vec, but might be empty of children's scope. Okay. And then might take a parent, pass along the parent, everything else just becomes empty, okay. Then you have all these checked namespace. What's this type ID thing? Okay, so it's just an ID. That's interesting. Okay. So these, okay. So these are what you end up doing. You'd end up generating IDs. You basically reconstruct the entire AST in checker, yeah. But you like have everything have an ID, so they're all unique because they could have the same name. And then you just have all these checked versions of everything. Okay. So you have namespace and then you have a checked namespace. You've got a var decal and you make a checked var decal. Go to the project struct. Where is the project struct? Struct project. This guy. Scopes, constants, type decals, enums, function status, blah, blah, blah. So okay, so this is like a checked AST, right? Is that could have been another name for this? Pub struct checked AST, right? Because it's just your AST with all your things. Okay. And then you also have this. You have this flat project is basically the checker state. Okay. And you have this flat as opposed to like nested with scopes, where I'm guessing these things just like point to like a scope ID in here or a scope index or something. You project at types. Type ID. Gotcha. So the IDs are just indices into these vecs. That's really interesting. Super cool. And then just a bunch of helper methods. Wow, this is quite a hefty file you got here. Yeah, scope is used to make sure can't access stuff you shouldn't. Exactly. Cool. So I'll do something probably pretty similar then. That's a good resource for sure. So project, is project like a standard name for that, or what? Is that like your invention, or should I call it project? I don't know. Struct project. Or like checked. You can just call it checker. Yeah, maybe let's do checker. Yeah, okay. And the checker is basically just going to run through the AST and just like populate fields. And then as soon as it hits a mistake or something, it'll just throw out an error. Okay. This is pretty cool. So I'll make a checker. How do we make a new checker? with this new thing? Well, new return self. Just like this. You do something pretty stupid when it comes to errors, and that is, let's make it a test. Configure test. Wait, did I do that right? How does this work? Wait, I always forget how this works. Configure test. Configure test. Wait, that is right. Okay. Mod tests. I'm not getting inline diagnostics, which is kind of annoying. You just have a diagnostics vec in the project. Okay, so you want to report all the errors it finds. Yeah, exactly. So you have a diagnostics vec in the project. That makes sense. And I never bail out of any function, ever. I just tell the checker to thug it out. Gotcha. Okay. That makes sense. So we'll make like a test. I don't know. We don't need any test yet, but like, so this checker needs to hold onto an AST somehow, right? So if I have an AST is a program, right? What is a program? I don't know. We need to go in here and make it available. Program. Okay, that is a thing. So we need to make this pub, and then I need to add a. How do we do this? Like kind of like this. Basically, is what I want. But over here, shoink. I don't need the lexer, but I kind of do need the parser. And then look at the parse namespace function. Wait, no, type check namespace. Type check namespace. This guy. It takes a parse namespace and takes a scope ID and a project. You don't need to store the AST. Then how else do I use it? The parsed namespace would be the program in your case. Are you saying you just pass it along? Like pass along a reference to it? Okay, so you're saying I could just have like a method called like parse program. Or not parse program, but like check program. That takes a program, which is a program. Why is... my language server not really working? Yeah, mute stuff, but I thought I did. Yeah, I did that automatically. Checker's right there. Oh. There we go. We do love Rust, chat. There we go. Okay. And it's gonna return what? Like a checked program. Using your convention. We'd have something like that. So like a checked program. Checked program. So what does our normal program look like? It's a vec of expression statements. Yeah, you got checked namespace. Let's find that. Checked namespace. Oops. It's got a name and it's just got a scope ID. So your namespace is pretty simple. So mine will have a scope ID too, I suppose. But it won't have a name. Yeah, type check namespace. What about like a checked something else, like a checked like a var-decal? You give it a name, type ID. Okay, so it has a type, whether or not it's mutable. What's this span here? What is this span? Oh, span's just like where it is. Gotcha. Hello, Ivy. I'm so tired right now, but I gave myself coffee, so now I'm just slacking until it wears off. How are we feeling today? We're feeling pretty good. Pretty good. All things considered. We're trying to type check this language now. Don't you have some sort of like, here, checked function. This is something a little more. Oh, here we go. Checked block. That sounds like what I want. Checked block, checked block. Shoink. Statements. This is what I want. It's a vec of checked statements. Okay, so we just check everything. So what's a checked statement? The checked statement. You don't remember what your type checker does? I just figured it out for you. Don't worry. I got you covered, man. So check state. Okay, so we just need a list of checked statements, and then we just check out each of these statements. All right, checked. All right. This is cool. So check program, takes program. It's going to Rust enums have if and while loops. You mean that? That's funny. Yeah, no, this is just an AST. Cool. Okay, so I'm gonna try to check some statements. So we have a checked program, which basically is has some statements, which is a vec of checked statements. Now, a program also has a scope ID, but the scope ID pretty much is always going to be 0, right? I mean, it's always going to be, or it's going to be kind of constant, right? It's the highest level scope there is. Check statement. So I have a checked statement, which we don't really know what it's going to be yet. I don't think you need a scope. Yeah, I don't think I need a scope ID for the checked program. I think you're right on that. A checked statement. Oh, right, you remember? What do you do? What do you remember? Guys, you know what's really cool? You do these like super chat things. Isn't that cool? And then I can hard it. Take note, guys. It's pretty easy. All right, you pass the checker state over to the code generator. What does that even mean? Look at code gen. Code gen. Code gen. What happened to my little file tree? I thought there was like a file tree. Here we go. Code gen. Inside the backend folder. LLVM.s. You have a bare understanding of Rust, but you're surprised we haven't encountered any funky borrow checker errors from what I've seen. You don't produce an actual... code gen namespace. Wait, code gen namespace. No such thing. Code gen appears 22 times. What is this? So this is like translating to the IR. All right, let's look. So, oh right, no compiler. Compile namespace. All right, compile namespace. Here we go. Oh no, lifetimes. Wait, so this takes a backend. I'm guessing this isn't something you made. This is probably something you got from LLVM. This is yours. Okay, you made this. Project, and then take the project. Gotcha, which I'm calling checker. And then you just kind of, oh, okay, you loop through all the things. You say like for each constant, for example, or let's find a simpler one. For each type decal, you just compile the type decal. For each function, you compile the function. LLVM backend state's literally right above. Oh yeah, check this out. Very nice, very nice. It's got a bunch of cool. All right. Let's give it a shot. So check program, check statement. Oh yes, we love LLVM. That's why we're not using it. Okay. So think. Check program, check statement. Okay, what is a check statement gonna have? Well, it's definitely gonna have scope, right? Scope ID. Scope ID. Check statement is an enum. Wait, my language doesn't even really have statements. It only has expression statements. So I'm pretty sure this is just gonna be like a thin wrapper around like an expression. If you know what I mean. So yes, okay. Checked expression we need to make. Okay, we need to make one with our bare hands. Okay. Checked expression. Okay, now what this is gonna have, this is going to have a scope. I mean, maybe this will have a scope ID. I don't know. This will probably have a scope ID. We'll probably stick the scope ID here. Okay, scope ID will be a scope ID, which is like a usize, but we'll call it scope ID. I like how you did that. It's nice. You go up here, you say type scope ID equals usize. Very nice, very clean. Oh yes, this is an enum. Smart person. Okay. Is there a lovely spec, or are we building it as we're going? I have no idea how to make a programming language. I'm just here like, what? Hooray. Scope IDs are passed to all the functions. Wait, you telling me it doesn't have a scope ID? Okay, so this is an enum. I understand that. And it's really gonna look at any type check function. Type check. That's back over in checker. Type check. Oops. Type check something. Type check namespace. It gets passed a scope ID. Cool. And a parse namespace, not that. Like a checked, parse, checked. Where's all your like these things? Like a checked inline ASM binding. Whoa. What a Chad. Sure enough, I'm not seeing any scope IDs. So type check expression is a good example. Type check expression. Where's the next one? Twink, twink, twink. I want the definition. This one. Nope. Type check expression. This guy. Where's this? Okay, here we go. Expression, parse expression, scope ID. Yeah, you pass it a scope ID, but this parse expression. Okay, type check expression. Scope ID, scope ID, scope ID. So there's no reason for it to hold on to its scope ID, is what you're telling me, because you just pass it along here. You pass the parse expression in, you pass the scope. Okay, gotcha. So, okay. Checked expression. All right, we're gonna do these one at a time. So, for instance, check program takes a program, returns a checked program. It'll just return a. This is really just gonna return like a checked program, where all the statements are the program dot o. This is about to get ugly. All right, hold on. We're just gonna hold off on that for now, or maybe not. Let's do this. How's that? Create scope function 2 on the checker, which returns a scope ID. Good idea. We're just gonna do this for now. Okay, I like your create scope idea. So, because a scope needs to be like a construct. So here we go, scope. Oh man, where to define things? Maybe a different file. No, it's probably not. Okay, so we'll make a scope. Scope ID. Okay, right here. Struct scope parent ID is an option of a scope ID. No? And then empathy is here. If you ever tried Helix, I find the default key binding is more intuitive than NeoVim or Vim. I literally just tried Helix for the first time yesterday. So funny you ask. I found it to be actually very nice. But then I discovered that it was going to take me a while to really get used to it. And then I discovered that I didn't really have much time. And then I discovered that NeoVim is actually still pretty good. And then I decided to stick with NeoVim from now. But I will maybe try it out for real sometime. My arm just came off. Ouch. It's like a ragged tear. Okay, it's back. Alright, a scope just has a parent ID. Is that kind of all it needs? It could have children IDs. It doesn't need to have children IDs because the children will be pointing at it. But it would make it convenient. Probably, okay. children IDs, or I'll just call this parent scope. Children scopes will be a vec of scope ID. All right, and then okay. Oh yeah, and you said we're gonna make this cool like create scope thing. So we'll just can I just make that sit on scope? What am I doing? Okay, hold on. I'm gonna make a new thing. I'm gonna make a thing called struct scopes, which is just a vec of scopes. How does that make you feel? Create scope should be on the checker. Oh, okay, so I don't need that. I just do it on here. Ooh, yeah, okay, so scopes will be on here. Scopes is a vec of scopes. That's not how this works. Okay, it's a vec of scopes, and then impl checker will have a create scope. Yeah, it'll take a myself. It'll have a parent ID is an option scope ID, correct? Okay, and then it'll return nothing. It doesn't need to do anything because it just mutates. Okay, because it's like a state machine. Optional parent. Yeah, I got the parent. Okay. And then returns the scope ID. Oh yeah, smart. Scope ID. All right, smart. You should tap into creating a programming language. Yeah, that'd be awesome. Probably an interpreter at the very least. Yeah, start with an interpreter. I've done interpreters. I've done dynamically typed interpreters, and now I'm trying to do a statically typed compiled. So it's pretty different, but it's fun. Create scopes. We're gonna create a scope. I'm gonna say self.scopes.push a new scope. Scope. Well, no, I probably need to find it out here. You mean crafting interpreters? Crafting compilers is not a thing, I don't think. There you go. Crafting compilers, though, would be amazing. If he did that, that'd be so good. Create scope. Okay, so we're gonna say let new scope equals scope. I need some other things here. A parent scope will be the parent ID, and children's scopes will be, an empty vec here, and then okay, fine. I see has a better idea. You're saying just do like the way I was originally doing it. Parent ID vec empty self.scopes.lang -1. Coolio. Wait, -1 is correct, right? If I just pushed on the third one, then I got a length of 3 and I need the 2. Okay, yeah, that's right. This is the kind of stuff you got to deal with when you have a zero-based language, guys. But lovely. That's a debate we still have to have. Okay. So now we can create scopes just out of thin air. So self is going to have some scopes, right? Scopes. Do we start off with an initial scope? I think we do. We do need to start off with an initial scope. What? No, you wouldn't. You'd still have to do -1 because you would have just added a scope. The initial scope would be a global scope. You wouldn't still have to do the -1 if you had a 1 based. Also, I just realized we need to add this to parent scope, right? Parent scope is none. And the children's scopes starts out like that. Why is this the wrong color? Because you want the last element, not the current. No, but look at this. I'm pretty sure I'm right. All right, thanks for stopping by Empathy and Ivy. See you guys. Look, if we say we had scopes that were like this, 1, 2, 3, and 4, we just pushed on a 5th scope. Then we want to return the index of this 5th scope, which is equal to the length of this, which is 5. Is that not right? Push increments the length by 1. I know that. But then after you push, you just return the length, and that's it. Is this not correct? Yeah. No, you're good, man. I was a little bit confused, though. Ivy was screaming in the background like, no. Okay. All right. But we do have to, if I'm going to go along with this whole like children's scopes thing, then I need to add this to the parent scope, right? So say like if let some parent ID equals parent ID, right? And here we have a real parent ID. Then we need to say like parent, we'll say like self.scopes parent ID dot push. Honestly, I don't think I've used the children's scopes once in my entire type checker, so I don't think you need it, honestly. Okay. Sure. So then I'll start with just this. And then it'll be easy to add if I ever need it anyway, so it's fine. By the way, we have all sorts of this going on. There we go. Why am I not getting like inline? Ever since I updated NeoVim this morning or earlier, I'm not getting like inline code lens style things. How did I do that? All right, so I'm going to create scopes. And so check a program, takes a program. By the way, what time did the stream start? 10:20, now it's 12:30. How long have we been going? And this chat is why I use this VS Code with Vim bindings. Yes, but then you lose the thrill of it. Half the thrill is it breaking. You know, every 12 to 15 minutes. Hang on, where is my? There's my browser. Shrink. Is this the stream? Is this our stream? Look at this, guys. Chat revenue, $2. It's because of that super chat I sent earlier. Where'd it go? Where's my super chat? Oh, it went off the top. That's a shame. All right, so we've been going for 2 hours and 11 minutes. So I might stop here-ish. I'm also kind of hungry for lunch, so. Hey. But I mean, that's a reasonable start, and we sort of got this kind of working. Not really the syntax highlighting, but oh no, Milk just joined. Sorry, Milk. You can always watch the recording afterwards, so shouldn't be a big deal. But all right, well, I will see y'all tomorrow probably. Until then, how do I end the stream? Uh-oh, here we go. This button. Goodbye, everybody.